Welcome to clickmyproject.com. Now we discuss about the product for scalable application dependent diagnosis of interconnect of SRAM based FPGAs. Next we see the abstract for the product. Field programmable gate arrays have been widely utilized in digital system designs. FPGAs offer programmable at relatively low dependent cost and good performance. An FPGA consists of logic and interconnects resources that permit to configure the uncommitted chip into the desired function for different applications. The common FPGA architecture consists of a two-dimensional array of configurable logic blocks, a programmable interconnects, and the programmable input and outputs. Currently, the programmable interconnect accounts for more than 80% of FPGA programmable resources. Therefore, the net into the interconnect resources are very vulnerable to fault both the manufacturing as well as the runtime process. For interconnect resources, FPGA testing methodologies are broadly classified as application dependent and application independent processing. The application dependent independent testing, also known as the manufacturing based on testing, and the application dependent, most of these resources utilize the specific design implementation of FPGA process. This paper presents a new methodology for diagnosis. Diagnosis or detect and location of multiple fault in an application dependent interconnect of SRAM based FPGA. For fault detections, the proposed techniques retains the original interconnection configuration and the modify the function of LUT using the new LUT programming functions. These LUT programming functions consist the 1-bit sum function. In addition, it utilizes the features such as the branches in the net as well as the primary of input and outputs of the FPGAs. The proposed method detects as possible stacked and the bridging fault of all coordinate in the single configuration. Fault detection requires the 1 plus log 2 of k test configuration of multiple stacked locations and 2 plus log 2 of k addition test configuration at locate then the one pair wise bridging fault. This fault location process following detection and location in the multiple fault are hierarchically identified using the walking one test and the adaptive approach of interconnect the SRAM structures. Net appropriate depending is accomplished by utilizing the features such as the presence of path of nets that are either disjoint or joint between the primary input and the least of one primary output. As validated by simulation of any type of benchmark circuit, these methods to scaling the fault identification of detect and locate based on the diagnosis methodology. Next we see the flow diagram for the product. First, the input bit data are applied to the 1-bit sum function. Because the 1-bit sum function consider the one separate LUT functions. These LUT functions look like any type of benchmark architecture designs. Our designs mainly used for sample design of in our base paper design. The 1-bit sum function consider the input data bits and based on the logic gates due to the and not, then the OR gate functions. These 1-bit sum function to apply the each and every LUT architecture in our SRAM based benchmark circuits. Thus the benchmark LUT are designed then to apply the branch selection process. The branch selection process based on the net selection for our the each and every LUT function selection activities. Then the branch selection process to apply the what are the branches are used for the each LUT activation and what are the branches are not used for our the LUT activation in our overall architecture designs. Then to calculate the unused input and output identification for overall LUT architecture. This unused input outputs to set the branch and not branch connectivity for our lookup table overall lookup table designs architecture. This to calculate the fault direction and fault location. The fault direction is mainly based on the FinFET functions. This the fault direction process mainly used for fault in fan out functions. The fan in fan out example for N6 node to be select for L7 and L5 for the branch selection, but to activate the L7 only. The N6 is whenever the N6 is 1 to set, they activate only for L7 to deactivate the L5 conditions. So the fault is occurrence for the L5 locations. This is the fault detection process, and to locate the fault location based on our base paper fault coverage designs rules. Thus the result designs rule to be fault coverage for which place to be fault occurred in our fault detection technique. Then to apply the final output results. These results are mainly based on simulate and synthesis results for overall architectures. And finally we see the output for the product. First we run the Xilinx IC project. Our scalable application dependent project was developed in VHDL language and to apply using the structural based modeling for our programming. Then to select the simulation and to run the simulate behavior model. So we open the iSim project. This project window used to simulate our scalable application dependent project. Just we apply the input for each and every node selection based on our base paper fault coverage tabulation results. Then to select the run the time specified on the toolbar. This our N11 and N5 node is our processing result, output result. This our each and every path. First we consider the net N1 to select. We consider the join path for PA1 path. This path to occur 1 and 0 process. When 1 the fault is not occurred, the 0 the fault is occurred. Then to detect and locate our path fault for our scalable application dependent process. This is our simulation result process. Then to consider the next path, we apply the input for net2 result. Just we activate the net2 process, we consider the path 2. This is our 0 for fault coverage in our scalable application process. This is our simulation result. Then we go to the implementation process. Just we run the RTL schematic diagram. This RTL process, what are the logical blocks placed in our overall architecture, thus the technological schematic process. This technological diagram, what are the lookup table and input and output functions placed in our overall architecture. Then go to the design summary process. The design summary process, we calculate the device utilization results in our architecture and to calculate the processing time result for our overall architecture.